Hey guys, welcome to Unit 8, Day 5 notes. We're going to start today with reviewing some factoring. So if you want to stop the video right here and try it on your own before I explain it, that would be a good review for you. Alright, now we're going to start with number 1. Number 1, we are going to do the chart, A times C over to the side. So A times C is 6, B is negative 5. Now we'll write our factor pairs of 6, which is 1 and 6, 2 and 3. So I need to multiply to get a positive and add to get a negative. So we multiply to get a positive by 2 positives or 2 negatives. Since we're adding to get a negative, we know that it's going to have to be 2 negatives. So negative 1, negative 6, negative 2, negative 3. That gives me negative 7 and negative 5. Negative 5 is what I'm looking for, so now we're going to bust the b. X squared, this busts up to negative 2x, and negative 3x plus 6. And now we group x squared minus 2x plus negative 3x plus 6. Now we take the GCF, which is x. I'm left with x minus 2. My GCF of negative 3, left with x minus 2. My funny GCF is going to be my binomial, which is x minus 2, and I'm left with x minus 3. Number 2, same idea here, the A times C chart. That gives me 6 and 5. But in this case, we're multiplying to get a positive and adding to get a positive, so I don't have to change anything. So 1 and 6 gives me 7, 2 and 3 gives me 5. Bust up my b into two different terms, which is positive 2x and positive 3x. Then we will group them. And remember, I can automatically group it here because there's a plus sign in the middle. Now take my GCF and another GCF. And that's my final answer. Last problem is number 3 is a 4-term polynomial. So we don't have to bust the b here. All we do is start by grouping. Take my GCF and take my other GCF. Take my funny GCF, which is x minus 4. And I'm left with x squared plus 9. That's my final answer. Number 4 is a GCF only. So I'll list my factor pairs of 4, which is 1 and 4, 2 and 2, and 5 b's. My factor pairs of 6, 1 and 6, 2 and 3, and 4 b's. And 7 is 1 and 7, and 3 b's. So the greatest amount of b's that they share is 3. And the only number that they have in common for the GCF is 1. But remember, we don't normally write 1 for the GCF. We just take out what we can, which is the 3 b's, or b cubed. And I'm left with 4b squared plus 6b plus 7. Now we're going to start our information for the day, our notes for the day. The first thing that we need to understand is the meaning of dots. This is a special type of factoring. Dots is the difference of two squares. It will always follow the form a squared minus b squared goes to a plus b and a minus b. So when we're looking at dots, it's always going to be two terms to begin with. We know that x is our squared term here, And we need to figure out what gives us 81 when it's squared. So we'll take the square root of 81, which is 9. I changed nothing here. I just identified which terms I could break down. So I have x squared minus 9 squared. Now I'll break it down into the dots form, which is a plus b and a minus b. So it's going to be x plus 9 and x minus 9. One more thing that I want to hit on before we go is difference. Difference is subtraction. So when you have a two-term binomial and you're trying to see if it is a dots candidate, it has to have a minus in the middle. Moving on to number 2. I'm going to do the same thing here. Check for a minus in the middle. We got that. And now I'm going to identify my square roots. So we have p squared, and then the square root of 100 is 10. And then I'll break it up into my dots. P plus 10 and p minus 10. Number 3, I'm going to check to see if this is a candidate for dots. Remember, dots is the difference of two squares. And since we have a plus in the middle, this is not a dots problem. And this cannot be factored. All right, for number 4, we're going to check to see if there's a minus in the middle, which there is. And then I will identify my square roots. 169 square root is 13. And now we can put it into the dots form. So it's y plus 13 and y minus 13. Moving on to number 5. It is okay if our a value is not just a variable. It can have a number in front of it, and we can still use that as a dots problem. So I'm still going to check for a minus, which we do have, and then break it down. So 4x squared, if I took the square root of 4x squared, that gives me 2x. And then 81 square root is 9. That breaks down to 2x plus 9 and 2x minus 9. Now moving on to number 6. Check for a minus. We have that. Now we take the square root of my a term to get 9p, and the square root of the second term to get 1. That breaks down to 9p plus 1 and 9p minus 1. Now number 7, a minus in the middle. Take the square root of my first term, which is 4m, and the square root of my second term, which is 5. That breaks down to 4m plus 5 and 4m minus 5. Take a second to try number 8 on your own. So we have 10x squared and 7y squared is what our two terms break down to. So I have 10x plus 7y, and then 10x minus 7y. It is okay if both terms have variables. We just have to make sure that we can take the square root of each to break it down. Now for number 9, we're going to verify that there's a minus in the middle, which there is, and then take the square root of both sides. But what I notice here is it's 2m squared. So 2 is not a perfect square. So what I'm going to do before I take my perfect squares now is look for a GCF. 2 can be divided into 2 and 72. So when I divide that out, I'm left with m squared minus 36. This still gives me a minus in the middle, and now I will check for perfect squares. So I have m and 6. And I keep that 2 on the outside so it doesn't change my problem. Now I can split it up again. M plus 6 and m minus 6 with a 2 out front as my GCF. Number 10, same idea here. I'm going to look and verify that there's a minus in the middle, but I need to check for a GCF because I see that 5 is not a perfect square. So I'm going to factor out a 5, and I'm left with y squared minus 25. Now I will identify my perfect squares. And break it up. Moving on to number 11. You see that this is a 4-term polynomial. So whenever you see a 4-term polynomial, you're still going to factor by grouping. So this one we're going to actually have to rewrite so that I can put a plus in between my 2 parentheses. Then I'll take a GCF of my first group, which is x squared, and a GCF of my second group, which is negative 9. I'm left with x plus 6 as my funny GCF and x squared minus 9. This is where dots comes into play because this term right here is a dots problem. We have 2 perfect squares separated by a minus sign. I'm going to rewrite it like I always do with the x as my square root and the 3 showing my square roots. If you don't need to do that, that's fine. You can go directly to dots, but I just want you to see where I'm getting my numbers. So I have x plus 6, x plus 3, and x minus 3. Now moving on to number 12. Same idea here. We're going to have to rewrite it. And then factor out my GCF. Now I take my funny GCF, which is 4x minus 1, and then x squared minus 4. Again, this is a dots problem, so we will have to break it down. I have x as my perfect square and 2 as my perfect square. And that is my final answer. Today's notes